All right, everyone, welcome back. We have 3.2, and this is going to be classes part 1. And this is going to be we're going to do several lessons on classes, and you're going to see us use this a lot going forward because it opens up some really unique doors, okay? Now, classes really became kind of new around C++ and are not included in the C language, although the C language has structs, which is an extremely similar thing, okay? But these types of structures, they open up doors for us that were not possible before learning them, and that's why I'm so excited about this. So let's talk about what you're going to learn in this lesson. You're going to learn first why we need classes or structs, if you're all about structs. What is this pivotal example where they come in and solve a problem for us? The next is you've already been using classes. Okay, you just didn't know it. You were using classes that other people wrote. And I'm going to show you some of those classes. Then we're going to get into how to make a basic class and how to make an object of that class with some live code. We're going to do Constructors Overloading. And, I think I actually took out talking about the this keyword and put that into the next one. So that's a mistake. In fact, let me get my ever so clean pointer out. I think we're going to do this one in the next one because it brings up class pointers, and I just don't think it's good to start about class pointers yet. In fact, yep, you can see that right there. We're going to look at deconstructors and heap memory, right? So if you remember that heap memory, you need to manually delete the memory. And so the deconstructor is going to be that place. So we'll get into all that. And then obviously we're going to get an assignment, a quick code, and a preview of that. And then I'm going to actually talk about these things really quickly and what you're going to learn in the part 2, okay? All right, so what's the problem? Why do we need classes? And the answer really is better organization and control when needing multiple separate versions of the same thing. That's a really convoluted definition there, right? So let's break it down this way, okay? If you look at this example, let's say we're making a game, right? And, games are going to have multiple players, and those players are going to have names. If we were to do this right now, we would have to hard code in, let's say it's a 3-player game. We have to hard code in 3-player names, give them some type of numbering system. So player 1 name, player 2 name, player 3 name, right? And each player's going to have a score. So player 1 score, player 1, 2, player 3 score. And you're probably starting to realize that that's redundant, right? Like if I know that I'm going to make a player or multiple players and they're all going to have the same type of variables, why do I have to essentially copy and paste and change a number system myself? Why can't I have a structure that does that for me? Okay. And, really start to take this example and think of things like Call of Duty Warzone. 100 players, right? What if there's not 100 players? What if there's only 93, right? Are you going to have just 7 variables sitting around that you're not really using because you had to hard code in 100 players, right? So it gets, this is what I call hard coding. We're going to start moving away from that. Now, you've already been using these things, okay? So let's get into kind of some definitions. What is a class? A class, are custom data structures that contain data members like variables and functions. And what they really are is they're a blueprint for objects to be made and manipulated. Again, that sounds really hard to understand. So let's put it this way. Think of a class as a folder, right? Like a folder on your computer. And in a folder, you're going to store a bunch of stuff, right? You're going to store files, maybe pictures, all things related towards whatever that folder was named, right? That's kind of what a class is, but for programming. It's a structure that can hold a bunch of variables and a bunch of functions that use those variables, okay? Now, when we say they are blueprints for objects, what we're saying is you can make multiple copies of that, okay? An object is a copy, and you can manipulate them separately. So, for instance, a string, when you've been making strings in C++, so if you've been making C++ strings, which you have by putting that word there, you have made a class. String is a class, okay? And that's why you have methods, right? So when you did this string, which is a class, you gave it a name and you gave it a value, you created an object of the string class. You called it player1 name and you gave it this value. When you did this string, the second string, it's from the same string class, but it has a different value. So when you call the same method, but from a different object, you get a different answer, right? So this would have been a string class, would have had a variable for player one, and it's going to have functions in it also, okay? Now an object, which I guess I kind of already got into that, is an instance of a class, a copy made from that class blueprint that can be manipulated, separated from other classes, right? So class is a type, object is a variable of that type, okay? So when you go to actually make an object, you go, this is the type that I'm pulling from, this is that name I'm giving the object, and then of course you can give it values, all right? Okay, let's get into a basic example, all right? And this is gonna look much different. There's a lot of things going on. We're just gonna break them down. For starters, I'm gonna kind of flow through these arrows. You need to use the class keyword, okay? So if you're gonna make a class, you go class, and then you give it the name. So here we're calling it player, which is kind of what the theme that we're gonna use for a while here is player. Now, for that string class, that name string would have been here. Now, if you're making your own classes, you should capitalize that name, okay? Hold on. Sorry about that. So the next thing is we have 3 what's called access specifiers. So specifiers that modify access to classes, other files, child classes, etc. Now, we're going to really dive into these more in the future, but for now, I want you to show that we're going to put a specifier of public, and then inside that, you can specify all the variables that you need public and all the functions that you need public. And then there's private and there's protected. Public means that all this stuff right here is visible outside and inside the class. It can be used anywhere inside the class, but it can also be used by other classes, other programs, etc. Okay? Private means that information is only visible inside the class. And you may be going, well, what's a case where that's important? Well, what if you're working with a passcode and you don't want other files to be able to manipulate that password without that class's permission? That's where private gets in. And we're going to talk about in future lessons all about how to use that effectively. Then we have protected, which is visible only inside the class and with inherited classes. Okay. So, you may be going, what on earth are inherited classes? That is something that we will dive into in future lessons, okay? Now, let's take a step back here, okay? Let's go, how do we actually, what's going on here again, right? So keyword, name, parentheses, start and finish. Everything in the class starts and finishes with parentheses, and then notice a semicolon here to end it, okay? That's the only time you've ever seen something like that. We don't do it with functions, okay? You put access specifiers. Now, I put private and protected even though there's nothing for it. If you don't have anything for it, you don't have to put them, but I wanted you to see that, okay? But you do need to specify public, even if it's the only one, all right? Because it'll default to something else. And then inside public, you make the normal stuff. Kind of like, if you think about it, this is what a regular file would look like at this point, right? And so you're putting it in here. So now this can only be accessed through the class, okay? Now let's see what I got down here. Yeah. Location of class declarations and definitions could be many places. If you notice that when we created functions before, we would have to put the definition way up high. We're going to put our classes before our main method right now and deal with that later. Okay, because it's really interesting how we separate those two in the future. Okay, so this is based off of that one that we just did. Okay, so basic class object, and we're going to make our own in a second here. All right. So if that class was above this main method, we'd be able to make a type. So look, we use the name of the class and we create an object. We give it a name, just like you would make any variable. This is the same thing, right? Like int name, now it's player name. Okay, so we created 2 objects. And then we're able to grab or save variables to it. So look at this. We use the object name and we go dot and the variable name. Now you may be thinking, oh, that's super new, but jump back here for a second. You've done that, except for before you used the name and you went dot and you passed it the method name, right? Well, now it's the same thing, except you don't use parentheses for variables. Okay, so I'm able to, outside the class, go, hey, I want to give that gamer tag, the name for Abacus. And I'm going to give the second one, because I'm calling from the second name, a different name. Okay? And this is kind of interesting because both P1 and P2 are using this blueprint. So they both get a gamer tag, they both get a score, and they both get their own identify method. Okay, And now look, we can manipulate these again. We got player 1 score is equal to 10, player 2 score is equal to 100. And then we can call those functions and they're going to print out separate things. Okay. So let's dive into an example and see what this looks like. All right. So we're going to kind of go over the example that we just did, but we're going to write it from scratch. Okay. And I think it'll be a little bit easier to understand when you see it written from scratch. So in order to make a class, we use the class keyword, class, and we give it a name. So I'm going to call it player. We use our open and close braces. And then here's the tricky part. You have to put a semicolon there. I'm unsure as to why this is. I just know that it is. Okay. All right, and so it looks very similar to making a function, right? Except for we put the keyword class. We have the semicolon at the end. Now, once we do this, we're really only going to be using the public access specifier for now. And then we tab out again, and we can make variables and functions, okay? So we're going to go string, which in fact, if I'm using string, I should include string. So I'm going to go string, and I'm going to give it the name gamer tag. And notice how I don't set it equal to anything. Okay. And then I'm going to go int score. All right. And I'm going to create that identify method, right? Which is going to, go, my name is this and my score is that. So I'm going to go void because it doesn't need to return anything. Identify doesn't need any arguments, parameters, right? And I'm going to go and just do a simple cout. So cout. My name is, and I'm going to say gamer tag. I'm going to do an end L. And then I'm going to go my score is and go score. All right. Now that's a class. This is a very simple class. Doesn't really get into the biggest additions of why classes are so important. It's just a simple example. Okay. Okay. So I'm going to save that. All right. Now I put this all above for a very specific reason. Okay. I don't want, like, how, we make a function and we have to do the definition up top and then I put them down below. For this, I'm putting it all up top here. So it is a definition and it is a declaration at the same exact time. The only time I'm going to do it the other way is when we start putting this class in a separate file. Like we make another file, we put it over here, and we use it in this one, which all major programs are multi-file programs. But I'm going to wait because it starts to get complicated. Okay. Now to create an object, it's just like making a variable. So I use the class name and I give it a name for the object. So player is the class. P1 is an object created of it. So P1 takes this whole class and goes, I want a version of this for P1. And then I'm going to go, I want another version of that, but for P2. So that there's a gamer score, there's a gamer tag and a score for each of those players that are separate. And look, this is how easy it is to make a third player. Player P3. Instead of having to sit there and go, oh, I'm going to need to make another identify method. I'm going to need to make another score variable, another string method to work with that player, or write an identify method that takes that information as parameters, right? This is how easy it is, right? So, I'm hoping you're seeing how effective that's going to be, okay? And now I'm just going to go P1, right? So if I want to change something about the object, the specific object, I use object name, and then dot. And after the dot, look at this. You can see this kind of populating everything that I can access. I got the variables and I got the function that I can access. So I'm going to give gamer tag. I'm going to give it the name, obviously, for Abacus. And then I'm just going to do P2. And we'll do gamer tag, dude, no, Master Chief. Okay. There we go. This is a throwback. All right. And then I'm going to give them scores. Obviously, my score is higher than Master Chief's. Okay. Now, when I call their separate identifiers, so I'm going to go p1.identify. That needs parentheses because it's a function. I'm going to call p2.identify, and that needs parentheses because it's a function. Okay. Let's give this a compile. All right, so G++, classes.cpp, and then run it. And look at this. My name is Frabicus. My score is 1,000. My name is Master Chief. My score is 100. Okay. Now you might be thinking this is more work than just hard coding it, because again, we're just getting to small examples on where classes are super powerful. But a real player class might need hundreds of methods, and I would prefer to write those hundreds of methods one time and then create the objects and manipulate them when I need to. Okay. So this is our simple example. Okay. We created a class. It had 2 variables. It had 1 function. We could have added more. All right. And I put it above main. And then we created our objects, and we gave those objects values to their variables, and then we called their functions. Okay. So let's get back and let's start looking at some more stuff. So I kind of hope that while you were looking at that example, you might have felt like I was doing too much to get those values in. And I was. Okay. Classes have some other special things about them, but I like to look at a basic example before we start looking at more complicated ones. All right. And one of the coolest things about classes is what we call the constructor. Okay. And now, of course, we can overload constructors just like anything else, but let's dive into what a constructor is. So a constructor is a special function that is automatically called when an object is created. Okay. Now, I want you to think about that. All it is really a function. Okay. But it's a special function, which means the compiler knows that when you create an object of player, to immediately run the constructor first. Okay. Now, this function has the same name as the class. So if you look at here, right, we have our 2 variables, and then you can see we have this function called player that's capitalized, because in order for the compiler to find this special function, it needs to have the same name as the class. So the class is called player. So the function, the constructor function, is called player with parentheses. No return type, not even void. You don't put anything, just the name in parentheses. Okay. Now, the purpose of the constructor is to initialize variables or allocate heap storage. So for instance, if you look at our overloaded constructor, which if you forgot what overloading is, overloading means that I have 2 functions with the same exact name. So this is player and this is player, but this player takes no arguments, no parameters, and this one does. Only one of them will run if I send a string and then an int. This one will run. If I send nothing, then this one will run. Okay, and you can kind of see I made this one to like set defaults, and I made this one to take a gamer tag name and a score so that we can create it off the bat. If you looked at our basic example here, we had to do those after the fact. So we had a lot more. We had 6 lines of code. We want to do this immediately creating the object, because as soon as you create an object, you need these things. So we want them done right away. Okay. So you can overload constructors just like regular functions, right? And that's an important thing. And I'm bringing that out kind of off the bat here. Okay. So when does the constructor run? Okay. The constructor runs when you create the object. Okay. And when I create the object, if I send no parameters, it'll give it default. If I send these 2, I can set them right off the bat. Okay. So look at how much more simple this is. Look at all the steps that we just got rid of. Player 1, right? I created the object, and notice how I didn't do equals. I put in parentheses and I sent the arguments. The first one was a string, so I put Frabicus for the gamer tag. The next one was points. Okay. Now this calls the one that takes those 2. Now, because I overloaded the constructors, there's also one where I just put nothing, not even an empty set of parentheses. I just put nothing. And that one calls the one with no arguments. And now I can call their respective methods again. Much, much more simple. Okay, so let's go back to our code and let's add in some constructors and see how they function. Okay, so we have our class, right? Class player. This is everything from before, but we're going to add the constructor in here. Now, I hope you're kind of seeing that we generally do variables, constructors, and then other functions as kind of the order. So I give it the same name as a class. I'm going to do the one with no arguments. I'd use the parenthesis or the braces, and I'm going to set those values. I'm going to go gamer tag equals, default, which of course, what I would probably do here in a real program to do a default is I would like randomly generate some random names. You know what I'm saying? I have like a list of 100,000 like weird names, and randomly pick one of them and make it that. And then, their score, obviously, when you first are created, you should have a 0 score. Okay? All right. Now, that's our regular one. Let's do our overloaded one. Okay? So I'm going to go player in parentheses, and I'm going to go string GT, like that. And then I'm going to go int score. Now I use different names, okay? I use GT and SC because gamertag and score were already taken here. And so I don't want that to be confusing. So I'm going to go gamertag equals GT. I'm going to go score equals SC. Okay, so that way when this constructor is called, it's going to immediately assign those values. Now I'm going to do this, and I'm going to say, I'm going to print something out. I'm going to go default constructor ran, like that, with an endl. And then I'm going to do another one in here because I want you to see the specific time that these runs. So parameter constructor ran. Okay. Now let's go down to where we run these down here, and we don't need these anymore. Okay, we can get rid of those, which of course we can still manipulate those manually because we left those variables as public. So don't think that you can't do that anymore. We just don't have to do it to make the player to begin with anymore. Okay, so to do the constructor one, I'm going to go here in parentheses. I'm going to put the arguments. So for abacus, can I spell? My goodness. All right. And obviously I start with higher points, and then player 2 and player 3 can just be default. That's fine by me. And look at this. I'm not changing anything else here. So I'm going to give this a compile, give it a run, and look at this. Look where those default constructors, where those constructors ran. Okay. Parameter constructor ran, default, then we see all this stuff printed out. So if we look at the code here, that's the same order. Look at this. Parameter constructor ran, default, then these run. Okay, so this is kind of proof. This is proof here that when you create this object, the constructor automatically runs. Okay, now the other reason I gave you that these are important is because they can allocate heap storage. And if your class needs any of that special kind of storage, the constructor is a really good place to kind of start that creation off. Okay, to do that allocation. All right, so this kind of wraps up that example. Let's get back. Let's look at some more things. Okay, so let's get into deconstructors and heap memory. All right, here we have a class, and you can see one of the variables is a pointer, and it's a pointer that is allocating memory. Okay, now it's done up here so that it's accessible in the entire class, because if it was done inside the constructor, it would only be accessible to the constructor, right? You got to remember that function scope. Okay. Now the thing about this is, when a function starts, when a class starts, we have a guaranteed starting function, right? Well, when a class ends, we also can have a guaranteed ending function. And this is really important for allocating your own memory. Okay. And if you think about it, it kind of makes sense, right? When this class runs out of scope and it gets deleted, it will also call this. Okay. At the same exact time, that deconstructor will run. Okay. And when that deconstructor runs, we're going to see this freeing of attack happen. Okay. Okay. So yeah, constructors automatically start, deconstructors automatically finish. Now, what's interesting about this is, our class here is a stack class, a stack memory class. And so we may not always see the deconstructor run because when this, the stack is managed by the operating system. And so it might handle the destruction of this, but, we'll see that as we go. Okay. So let's get into a live example. Okay, so we're here in our class, and I'm going to change, well, I'm going to leave this class the same, but I'm going to add in our pointer. So int star attack, and it's going to be set to, or, we're going to call malloc, which of course, if we call malloc, we need to include the appropriate library. So include the C standard library. Okay. And then, we're going to set some stuff up for a second, but I want to introduce you to the best practice here. Okay. The best practice, because memory leaks are some of the biggest problems that programs face. When you write a malloc, you need to write a free. Okay. At the same time, we wrote a malloc for attack. We need a free for attack so that we can free that space up. Okay. That means we need a deconstructor. So we're going to use this little wavy symbol. I actually don't know the name of that symbol. Okay. To find that symbol, if you go to your keyboard and you look at the number 1, it should be to the left of number 1, and you should have to shift that key. Okay. And then we're going to give it the same name as the constructor. Okay. And it's not going to have any return type or any parameters, and it shouldn't have any parameters ever. Okay. Now in here, I'm going to go free attack. Now I know I didn't finish the malloc. Okay. But this is good practice. You write a free every time you allocate. Okay. All right. Now I'm going to add in for our deconstructor here that the deconstructor, I can spell this, ran. Okay, and I'm going to show you this situation where this runs. Okay. All right. So now let's actually allocate the storage. So we want the size of an int. Okay. And then that returns a void pointer. So we need to cast it like that. Okay. Cast it to an integer. All right. Okay. So that's a lot here, right? Definitely a lot. All right. Let's give this a save and compile. Okay. So let's compile. Thank God there's no errors. We run it and look at this. Okay. We see constructors ran, a bunch of our methods ran, and then our deconstructors ran. And if you look at our main method, we never called the deconstructor, right? But when this main method was ending, right? That means that all this is in the stack. Okay. So this is ending, and the operating system goes, okay, this program is ending, so I need to clean up all the stack memory, okay? And it's going to go, well, we have a player class, 3 objects for it in the stack memory, and we need to clean them up, so we're going to run the deconstructor, okay? And that's why it's so important to do this, because you may not always be the one deciding when this player class gets destroyed. If I did not put this free here, then it is possible that this memory is still being used even though my program ends. Now, your operating system is supposed to keep track of all these things, but it's not a guarantee, okay? And often memory leaks are the biggest issues that programs run into, which is why I'm slowly talking about Heap and not just doing like one big video on it. I'm just like bringing it into examples where they're important, okay? All right. So that's a deconstructor. And it kind of dawns on me when I did, let me just jump back here for a second. When I did my initial example, I didn't really talk about this enough, okay? When you make a deconstructor, you use that little wavy symbol by the 1, you give it the same name. That's how the compiler knows where to find it. That's how your operating system is going to know where to find it, okay? Now let's jump back here a little bit, all right? We're pretty much done. We got to look at our quick code in a second, but I want to talk to you about, there is a part 2 for this. Okay, this was all very basic class stuff. Okay, we did constructors, we did deconstructors, we did making variables, methods, and objects. All the basics. Okay, there's a lot more about classes. Okay, for starters, we have static. Okay, which is a key word. All right, which is going to be pretty important for classes. We have class pointers and a this keyword. So remember, if you can have a pointer to a variable, you can have a pointer to a class. We're going to go over encapsulation, which this is a style of using classes. And it's going to really be the style that we're using for our player class, which is going to get, we're going to continue to use that player class. Okay. We're going to go over when to use private specifiers, which is really all about encapsulation. And we're going to talk about how to put our classes in multiple files. when you start making classes, your classes are going to get huge and you don't want them in the same file as your main method, okay? And then in order to do multiple files, we need to know what a header file is, okay? And if you go back here, when I guess none of the includes are there. Okay. These are header files. You're including a header file that tells me where to get the classes and the methods and the functions for all this. Okay, it points me, it's like all the definitions for different files. Okay, and we're going to go over how to make our own so that we can use them. Okay, so that we can do multi-file. Now, before we do classes part 2, we're actually going to take a pause and we're going to do the next stuff. We're going to do, we're going to work on doing multi-files before we do them with classes. Okay. All right, so we got a quick code here, student class, and whoops. Okay. Where's my pointer? There we go. All right, student class. All right. We got some advanced opportunities, just regular opportunities, right? So you're going to create a student class, and it's going to have the following variables. It's going to have name, ID, and GPA. Okay. You should have the following constructors: student, and student that takes a name and an ID. Works just kind of like the example that I gave you. And then you should have the following methods: identify. Okay. Now, if you want a challenge, you can do an advanced opportunity with the calculate GPA method, which we're going to get to doing that for a regular opportunity. Okay. But, first time seeing classes, I don't want to overdo it. I want you to get comfortable even making a class before we start really getting crazy with it. But you should give this a try. Calculate GPA, and I'll talk about what it means in a second. Now, the default constructor with no arguments should set default values for name, ID, and it should zero out GPA. And the overloaded constructor should set name and ID to the argument sent and zero out GPA. Now, the identify method should just identify all the variables: name, ID, and GPA. So you've really done that. That was a lot of the examples that I went over. Okay, and I'm okay with that for right now because this is basic. Okay. Now, the advanced opportunity for that calculate GPA method should take an array of letter grades A, B, C, D, F, and convert those to their GPA score of 4, 3, 2, 1, and 0, and then calculate the GPA and send it to the class variable GPA. Okay. So what I mean by that is, it'll take an array of characters with their letter grades, which would be one of these. And then you're going to loop through that array and go, well, if it's an A, that means it's a 4, right? If it's a B, it means that's really a 3. If it's a C, that really means it's a 2, D, 1, F, 0. And then you need to calculate the GPA, means averaging those, the integer values of those. And then you're going to set it to this GPA. Okay. Sounds pretty complicated. It is kind of complicated, which is why I'm leaving it as an advanced opportunity. Okay. Now we will be using the student class for most of this unit for the quick codes. So if you don't do this one, you're not going to be able to do the next one. And that's another reason why I'm keeping the first one pretty simple. Okay. And so that's, again, another great thing about classes. We don't have to start over all the time now. Okay. We can take what we've done with the student class and go, man, I want it to have more functionality, and just keep adding to it over time instead of starting from scratch. Okay. So you will need this student class for like the next 5 quick codes. Okay. Now I know I normally do an example, but I'm not doing one for this time because, basically the lesson was the example. Okay. And, finally, if you could give the channel a like and subscribe, I really want to see if the things I'm teaching you guys are valuable, right? And I want to open up that feedback to a bigger scope. So if you could do that, I really appreciate that. And I would see you guys next time. All right.